will be done from end of the doubly linked list, that is delete end. So the control will get transferred to the delete end function from the main function. So delete end function from the main function. We are having these three nodes now. So this is what is delete end function. This is what is the delete end function. So let us assume that we have these nodes. As well, there are 8 fields in each and every node. Right. So head is the pointer which is pointing here. Head is a pointer which is pointing to the header node. Right. Perform the establish the linking, and this is pointing to null, and this is also pointing to null. These are the different 3 nodes which are present in our doubly linked list. So how the deletion will take place? So delete end function. This is the definition of the delete end function, and we have received this header. We have received this head pointer, which is pointing to these existing nodes, Node from the linked list. If there are no nodes in the doubling linked list, it is difficult for us to delete the nodes, or it is not possible to delete the nodes. So doubly linked list will be empty only when the header is pointing to null. In this case, the head pointer is not pointing to null. It is pointing to a node which is part of the doubly linked list. So if this is the case, we are going to print no records to delete. Now in this case, this if statement is not true. That means there are nodes in our doubly linked list. So next we will check. Is there only one node in the doubly linked list? Say for example, if this is the status, right? For this if condition I am showing. If the doubly linked list is something like this, that means what is head pointer next? So this is head pointer next is null. Head pointer next is null. This is head and head pointer next is null. In this case, what it is true. It is true. Not of true is what? False. On head pointer next is null. Not of null is what? The entire condition will become true. If the entire condition will become true, then it is going to return null, saying that there is only one node which will be deleted. If there is only one node, nothing is left. We are left with only null value. So when there is null will be trying to doubly linked list. It is possible that the doubly linked list has only one node or more than one node. If it is having only one node, just delete it. If you delete this, what happens? The doubly linked list will become empty. In that case, we will simply return null, saying that doubly linked list has become empty. Now in our case, this is also not the case, right? This is also false. Now which one will become true now? Obviously it indicates that there are more than one nodes present in the doubly linked list. That indicates that there are more than one node present in the doubly linked list. Right? So take a temporary node PTR which points to the temporary node PTR equal to head. Then till this condition is true, you go on advancing your PTR. That is PTR pointer next, because we are deleting this node. We are deleting last node. If you are deleting last node, you have to traverse up to last but one. So for example, if there are 10 nodes, if you want to delete 10th node, you have to go up to 9th node. If there are 20 nodes, if you want to delete last node, that is 20th node you want to delete, you have to go up to 19th node. So that's what we are doing. While PTR pointer next, yes, it is true. PTR pointer next, PTR pointer next, it is true. That means enter into the while loop and execute this statement. What it says, make PTR to point to the next node. Make PTR to point to the next node. Instead of pointing here, what happens now? PTR is pointing to the next node. Yes, PTR is pointing to the next node. Now again repeat the for loop. Not for loop, while loop. Again check the condition. while PTR pointer next. Is it true? PTR pointer next. No, it is not true because it is pointing to some null. There is no node here. PTR pointer next. There is no node. That means now we are pointing at the node which is present just before the last node. This is last node. This is last node, and we are pointing here. We are pointing to previous node to the last node. That means now by pointing to this node, you can delete this node. Very easy to delete this node. How to delete this? Just PTR pointer next to this node. So traversal of this while loop is over. Traversal of this while loop is over. What is next thing? You just want to delete this. How you identify this? This is identified by PTR pointer next. This is identified by PTR pointer next. Just free that. Execute this statement. So what happens? This node will successfully get deleted now. With this statement, we are deleting this node successfully. Next, where PTR is pointing to this node. Obviously, this should contain null now. So when I am deleting this, what I will do, I will erase this node now. Right, this node has been erased successfully. Okay. So when you erase that node, what is the next statement? We should make this as none now, because earlier it was containing pointer to the next node, but there is no next node now. What you should do? Make that contain the null value. That is PTR pointer next is equal to null. So PTR pointer next is containing null now, because now this will become the last node. Earlier this was the last node. We have successfully deleted it, and now this will become the last node and return the header node, return the head node. That means now after deletion of the last node, this is what is present status of our doubly linked list. Head is pointing to first node of the doubly linked list, and there are two nodes in the doubly linked list. There are two nodes in the doubly linked list. So once the return statement is executed, it will go back to the caller. The control will get transferred to the caller. From where we have come, you should go back to the main function. So now control will transfer back to the main function. So 1 second. Sir, class ಅಲ್ಲಿ ಇದೆ ಮುಗಿತೀರಾ sir? Sir, class ಅಲ್ಲಿ ಇದೆ, I'll call you back. Okay, thank you. So now the control will go back to main function. Am I audible? Is there any disturbance in the voice now? No? Is it clear? Are you connected properly? If the voice is coming to you properly now, because I got call in between. Can you hear me properly? Can someone respond?
Yes, sir.
Okay, thank you. Right, the delete end is over. Now let us check the next function. What is that? Insert front. So for the existing doubly linked list, we want to insert a new node for this existing nodes. So now the control will get transferred to the new node. Just now, very recently, what we have done, we have deleted one node from the existing doubly linked list. So there are two nodes which are remaining now. Now let us go to the definition of insert front. Go to the definition of insert front. So let us go to the definition of insert front function. No, this is double-ended queue. I just came back. This is what is insert front function. This is what is insert front function. Now before we insert the nodes at the front, I will write the status of the existing linked list. Pointing to next node, it is pointing to previous node. And this is head pointer which is pointing. Here it is null, left pointer is null, and right pointer is null here. So this is what is existing doubly linked list. This is our existing doubly linked list. Now what is our intention? We want to insert new node here at the front. So take a temporary node, allocate memory for that. So first what I will do, I'll take a temporary node, right? Its name is temp. A temporary node has been taken, allocate memory for that. Ask user to enter those details. What details user will be giving? SSN name, department designation, salary and phone number. So SSN will be stored here, name, department will be stored here, designation will be stored here, salary will be stored here and phone number will be stored here. Now our temporary node is ready. What is the next task? We have to perform attachment between these two. We have to perform attachment between these two. Head is the pointer which is used for identifying this node, first node. Temp is the pointer which is used for identifying the newly created node. Just by performing linking, we can insert the new node, right? So what I am doing, first this statement, what it says, make these two as null, because before insertion it is possible that there are no nodes in the doubly linked list. If there are no nodes in the doubly linked list, what happens? This itself will become first node of our doubly linked list. This itself will become first node of our doubly linked list. Pointing to null temp. Only when there are no nodes, this itself will become first node. But in our case, there are two nodes. So what we have to do? We have to perform linking between these two now. We have to perform linking between these two. So as we are going to establish the linking, I will erase these pointers, right? What is that? Head pointer previous equal to temp. For this head node, this previous pointer should point to what? Previous pointer should point to temp. That's what it says. Head pointer previous equal to temp. Make the head pointer previous pointer to point to the temporary node. Then obviously this should point to this node. That is temp pointer next is equal to head. Make temp pointer next to point to head node. Make temp pointer next to point to head node. Now this will not become the head node now. This will become the head node. For that purpose, what you have to do, return temp. That means this we are returning as the head node, not the head as the head node. Because in all other functions, you must have seen that we are returning head. Because whenever you are inserting at the front, this node will not be the header node now. So no more it will be the head pointer. What happens? This should become head for the next iteration or for next all operations. For that purpose, what we are doing, we are returning temporary node as the new head node. We are returning this temporary node as a new head node. What happens? This overall status will be returned. This overall status will be returned to the caller. So caller means what? To the main function. So in this, what happens? The new head will be added with the third node at the front. So this is how the insert front works. Now next we have delete front. So whatever we have added, let us try deleting that. So control will go to the delete front function. Control will go to the delete front. So there are three nodes now presently. Now we'll go to the delete front function. So let us take the present status of the doubly linked list. Right. So presently we have three nodes. Last field is containing null, first field is containing null, head is the pointer which is pointing here, next pointer is pointing to next node, previous pointer is pointing to previous node, next node and previous node, right? So here it is null and here it is also null, right? When this is the case, what we want to do, we want to delete from the front. That means we want to delete this node, then we should be having this as a next head node, right? First we check, is there only one node? Are there zero nodes in the doubly linked list? If that is the case, if there are no nodes, we cannot delete. If there are no nodes, we cannot delete, and simply we print saying that there are no records to delete. Else part. If there are only three possibilities, there are zero nodes in the doubly linked list, or What is the second possibility? There is only one node. There is only one node. 0 nodes and 1 node. And what is the third possibility? Third possibility is more than one node. Third possibility is more than one node. In this case, 0 nodes is failing. Is there only one node? Check that. Head pointer next. Is it null? Yes. No, it is false. The entire thing becomes false. Why? Because in our case, there are 3 nodes. So this is also false. This is also false. So which is true now? The next part is true. So next part is true. What it is doing? We are simply returning next node to the head node as a new header node, new head node. What we are doing? Head pointer next. What is head pointer next? Head pointer next is pointer to this node. So pointer to this node. Just to return what we are doing, just to return pointer to this node. Just return pointer to this node. Then whenever you return, it will not header won't be the header node because we are just returning this pointer. Because whatever you delete, whatever you perform delete front, we are returning pointer to this. Whenever you are returning pointer to this, this will become new head. This will become new head for further operations. This will become new head for further operations from the doubly linked list. So go to the definition, see what is happening here. After performing delete front, we are taking the returned value and assigning to the new head. So what we are getting return from there? We are getting return head pointer next is being returned. So from that function, what is being returned? Head pointer next is being returned. So I'll go to delete front and show you once again. Right? If we can see a delete front, what is being returned? Head pointer next is being returned. That means pointer to this node is being returned. Then that will be assigned to the new head. That means second node will become the new head node. Now second node will become the new head node. So last case, double-ended queue, implementation of double-ended queue or DQ. Is combination front and rear end. So deletion, insertion, deletion and insertion that will take place from both the ends. So these corresponding functions. Now the control will transfer to the double DQ function. Definition of the DQ function. So if you can see in the DQ function, no other code is written. So in the function for double-ended queue, in double-ended queue we have not written any extra code for that. So in that function itself, what we are doing, giving choice for the user. What is that? If you want to demonstrate a double-ended queue, give choice 1 for insert front, choice 2 for delete from the front end, insert from the rear end, choice 3, delete from the rear end, then display and exit. So same all the 4 functions only we are using, the previous 4 functions. For all the choices, if you can see here, we are calling the same previous functions only, whatever we have studied just now. A display function for displaying elements of the double-ended queue. So for if you want to perform insert front, call the insert front function. To perform delete front, call the delete front function. To perform insert end, call insert end function. To perform delete end, call delete end function. For display, call the display end function. So which all the functions which we have discussed, the same functions will be called. The same functions will be called. So now I need not explain you all those functions once again. So finally, for any invalid choice, we are going to view it as an invalid choice. So this is one sample demonstration of the output, what you can see. You can later on, you can, any of these sheets are given to you, you can trace the sample output. So from the main function, we have seen all the 7 choices. Case that if you give case here, that is exit. And if you give any other value other than those 1 to 8, it's going to tell, it's going to ask you to enter the valid choice. So these were the